This is problem number 7 on page 39 of the Giancoli textbook, 6th edition. You're driving home from school steadily at 95 kilometers per hour for 130 kilometers. It then begins to rain and you slow to 65 kilometers per hour. You arrive home after driving 3 hours and 20 minutes. How far is your hometown from school is the first question, and the second is what was your average speed? I find that this problem, although you're for the entirety of the problem, you're basically just using this concept that the average velocity is going to be equal to the distance traveled over the time interval. Although the concept in itself is straightforward, this is your real first exposure to problem-solving methods in physics. So I think you'll benefit from drawing a sketch of the problem. So I'm going to do that here in red. We've got two situations. We've got the car here that's driving to school over this first interval, and I'm going to call that first interval 1. So over the first interval we have a known velocity. That average velocity is given to me in the problem. It's 95 kilometers per hour. And it also is given to me in the problem that the distance traveled, I'm going to use subscripts of 1 here to describe that. The distance traveled during that time interval is 130 kilometers. Secondly, there's also, after you hit this rainstorm now, the car and the driver slow down to a more sensible 65 kilometers per hour. So I'm going to call that average velocity 2, 65 kilometers per hour. And that the distance traveled during that second interval is not known. And likewise, the time traveled during the second interval is not known. So these two unknowns create a problem. Obviously, using this equation, velocity is equal to distance over time here, we can't solve with two unknowns, but you should also recognize that we can solve for t1 in this problem. And we should also recognize that there's a relationship between these two times. The total time, which is given to you in the problem as 3 hours and 20 minutes, or 200 minutes, is going to be equal to the sum of t1 and t2. So if I can resolve t1 in the first equation, perhaps in an intermediate step, I can then use this 200 minutes to then solve for the unknown t2. Once I know t2, I can then figure out the distance traveled during the second interval, or during the time that it was raining over here. And if I know that distance, I'll draw some rain in here. And once I know that distance, I can add then d2 to d1 and answer the first question, which is how far did you travel during the entire time? So the most important thing for you to do at this point is to recognize that although the mathematics and the physics is pretty basic in this problem, it's really the approach to problem solving that this question is really asking, is teasing out of the student. Okay, so let's go ahead and get started. Let's go ahead and recognize then that the first step would be to find t1. And I'll start with an initial equation. I can say that my average velocity during the first time interval is going to be d1 over t1. Rearranging this to solve for t1, I'm going to get t1 is equal to d1 over v1, and I get 130 kilometers over my average velocity, and it's up to you. I kept it in kilometers per hour, so I get 95 kilometers per or over hours. Notice that I've kept the units here in kilometers and in hours, which means that my time answer in this case, which happens to be 1.37 hours, has to be in hours, right? It's not going to be in minutes, it's not going to be in seconds. I can then convert it from here, which I've done, and I get 82 minutes. Okay, so now that I'm moving on to step 2, which is basically going to be to find t2. So I can recognize that t2 is going to be found by recognizing that the total time is going to be t1 plus t2. I know that the total time is 200 minutes, and I just found the time during the first interval as 82 minutes. So now I can say that the total time minus t1 is going to be equal to t2, or 200 minutes minus 82 minutes is going to be 118 minutes. as the time during that second interval. I now know the time during the second interval, so my next step then will be to find the distance during that. So during the second interval. So I've got my average velocity is going to be the distance in the second interval divided by the time during the second interval. Everything is known except for d, so I'll rearrange the equation. I'll get average velocity times time is equal to d2, or the distance traveled during that second interval. In this part, it can be a little tricky. You can leave it in kilometers per hour and convert it to meters per second. You just have to have some unit consistency. So what I chose to do is leave it in kilometers per hour, which means then that my time, which I figured out was 118 minutes, I had to convert to hours, and I got 1.96 hours. Of course, 118 minutes just being just under 2 hours is equal to D2, so X that. That's not D2, it's D2. Okay, so 65 times 1.96, I get 127.5 kilometers being my distance during the second interval. Of course, the last step now, what's the total distance? D total, you should recognize, is going to be D1 plus D2. Adding those two numbers together, 130 kilometers plus 127.5, I get 257.5 kilometers. Truncating for significance, I'll call that, 260. That's a 2 right there, kilometers. That's the answer to part A, but I'm not quite done. The second part of the question asks me, what's your average velocity? In this case, the average velocity is not simply the average of the two during step 1 and step 2. By definition, average velocity is, again, total distance over, total time for the average velocity during the entire interval. So the total distance that I traveled was 257.5 kilometers. Notice that I've put in that intermediate, non-kind of truncated number, 257.5. I haven't used 260 here. This is an intermediate step, and I'm going to divide that by 3.33 hours. I chose 3.33 hours because I want my answer in kilometers per hour. If I had put it in minutes, that's fine, but my answer would be in kilometers per minute. We know that it's 3 hours and 20 minutes, or 200 minutes, but again, I've converted this to hours, and my final answer here should be 77 kilometers per hour.